Good morning, colleagues. Today we are going to solve exercise 326 from the book Fundamentals of Electrical Circuits. In this exercise they ask me to determine the tensions B1, B2 and B3 by applying node analysis. The first thing I am going to see is that let's look here. All this is a single point and we can consider it as a single point. All this that is here is a single point and this would be the other point that is here. It is a point that is worth 0 volts because they show it at once the reference to ground. Okay. Using that analysis, I am going to call the first point B1. What I am going to do first is draw the direction of the currents by doing a visual analysis and then this one. We do the node analysis and I notice that there is a 15-volt source here, right? And the positive is up, which tells me that the current may be going up through this resistance. At this point we say that all this is a point. I have to look at what currents come in and out. This current comes in. Here we observe that the first current that leaves that point is 3 amperes. If here within a current we know how much it is and 3 amperes are going to come out here. Let's observe that here they give us a current called Y sub 0 due to this slope source. This is where the current I sub 0 comes from, and here I say that the other current is another current. It will reach this point V2 and will join with a current that will come from here. I put this one up because the dependent source is telling me that it is going up, so that source will generate an upward force. So here at this point it is added. This is added to this and I say that the other current is coming here. Let's observe that at this point 3 amperes enter and 0 enter this one, and I suppose that the remaining one has to take its way to one side, and I suppose it is this one. This source of voltage helps me heal the one below. Then the current could come in this direction. Ready. Marking the direction of the currents, we can give a name, that is, I'm going to call it M1 and I'm even going to call it N2. This one. I'm going to call it N3 of course. Well, this one and 3 is the same. N0 well, I already hit this one. I'm going to call it N4. N4. I'm going to call N5 and I'm going to call this N6. So let's do the analysis of node 1. Here in the node. I note that in node 1 I am going to put the always the same, the currents that leave, the currents that enter and leave this point. First, what is the current M1 that is this one that is here? N1 is going to be equal to what comes out, which is 3 amperes plus the current N3 plus the current N2. But the current N1 which is 31 is the most. In this direction I say that the tension on the resistance, the tension that this resistance has on the resistance would be 15. Minus the voltage of 1 over 20 is 15 minus V1. Because if I say that the current goes there, I suppose 15 volts more than V1, or 1. But I guess that's it, because I read the direction of the current. That's going to be equal to 3 amperes. If this is current voltage over the resistance, 3 amperes plus the current and 333 the zero current. This current that runs here is voltage V1. V1 minus V3 over 10 ohms. That's the current and 3 to the current and 2 and 2 up to here 1 minus V2. About it. Okay, so we start applying algebra here. It would be 15 over 20 minus V 1 over V equals 3 plus V1 over 10 V 3 over 10 plus V1 over 5 volts 25. Ready. I have this here. What I'm going to do is apply algebra. I'm going to put the variables on one side and the same on the other side, that is, everything that has a variable. I'm going to pass this over there. And I'm going to pass this over there. Of one about them. Minus V 3 over 10 1 over 5 volts 2 over 5. Ready. And what happens to the other side? It would still be plus V1 over V is going to be equal to 15 over 20 minus 3. Okay. Now what I'm going to organize is I'm going to add everything that has V1, everything that has V2, V3, and in the end I'm going to have 7 over 20 versus 1 minus V25 minus V310. All of that is going to equal minus 9 over 4. I'm going to multiply by 20. You are going to eliminate the denominator. When multiplying by 20 in the equation, I will end up with 7 volts 1 minus 20 would be 4 volts 2. V3 equals minus 45 and multiply by 20 as it is to eliminate the denominator. Sometimes it is not even necessary to do this step to have a much clearer equation, but we could do it this way. So this would be our first equation. I'm going to put it here to have more space. 7 volts 1 minus 4 volts 2 minus 4 V2 minus 2 V3 equals minus 45. Okay. Now we're going to work with a tension with node V2. Okay. At node V2 we stop here. We add the currents that between the current and 2 and the between the current and 4 will be equal to the current that comes out, he says. So the current and 2 is the same as we had already said, which is V1 V2 over 5. Because the current goes from this point, assuming that versus 1 is greater than V2 plus the current in 444. That is, one dependent source depends on the current and 0 that is here, so it would be 4, 4 and 0. This continues to be a source of tension. No? Here is the symbol for current, a source of voltage. We have to treat it as a voltage source minus V2 over 5 minus this is going to be equal to the current 5 and its V2 minus V3 V2 minus V3 over 5 ohms. Okay, I'm going to start separating them. I have here V1 over 5 minus V2 over 5 plus 4/5 and 0 minus V2 over 5 equals a V2 over 5 minus V3 over 5. So I sub 0, which is what we have to look for, and the current that comes through here, which is the same current, and 3 the current that circulates through here then, and sub 0 is V1 minus V3 over 10. Since I sub 0 is a current, it has to be voltage over current, voltage over resistance, the current. So we have to replace this here. Then I just replace. I know that V1 over 5 minus V2 over 5 plus 4/5. That multiply AI sub 0 and sub 0 V1 minus 3 over negative V2 over 5 is going to be equal to V2 over 5 minus V3 over 5. Okay, so I start working on this. Hey, well, here we have to apply to minus V2 over 5. So I multiply this 4 by each term above and the 5 by the 10 will be more. Four volts 1 minus 4 volts 3 over 50 minus V2 over 5. Hey, let's notice that this one is here. From this side I'm still going to pass it to the other side. Once will be less. V2 over 5 plus V3 over 1 equals 0. I continue to operate this, which would have V1 over 5 minus versus 2 over 5 plus E would be 4 over 50 V1. If I'm separating this 4 volts 1 over 50, then I take out the parenthesis in the plus sign and this minus sign because it would be minus 4 over 53 minus versus 2 over 5 minus V. 2 over 5 plus versus 2 plus versus 3 over 5 equals 0. Well, now everything that V1 has I'm going to operate here. 715. 720 over 25 of V1 minus 3/5 of V2 plus 325 V3 is equal to 0 if I multiply it by 25 to eliminate this, and it would not be necessary. We can leave it that way. The idea is to just leave one variable V, one variable versus 2 once, versus 3, but we could leave it a little smaller or we could leave it like this. If we drive well, then I multiply it by 25. Here I have 7 volts 1. This V 15 V2 minus 15 V2 plus 3 volts 3. I already have my second equation. Okay, if you have any questions, you can rewind the video. Check yourselves with the calculator to see that everything is fine. Now for the node V3 all this. We are going to look at the currents that enter the the currents that leave the currents that enter this node. Well, the 3 amperes enter first, that is, all of this here. In all of this 3 amperes enter the current, and 3 is the same current, and the current enters and the current exits, and 6 here. Now, this would be 3 plus the current, and 43 has it here. It would be V1 minus V31 minus V3 over 10 plus the current and 5 the current 5 V2 V3 over the current and 6. Let's observe that the current is the one that comes this way. Here there is a force exerted by V3, and since this source is downwards, instead of opposing it here the force is added. That same side would be plus 10 over 15. We begin to apply that it would be 3 plus V1 over 10 minus V, 3 over 10, minus 5, minus V, 3 over 5, and we can separate this. It would be V3 over 15. Plus 10 out of 15. Ready. Now I'm going to move everything to one side of the same. Everything that has a variable and what is constant to the other. I have 1 left over 10 versus 3 over 10 plus V2 over 5 volts 2 over 5. V1 as 3 volts 2. This minus V3 that. It's 3/5. If we go here, what does this one have? Positive sign goes to the other side. It would still be minus 3/15 and here I would have 10 out of 15. This is this and I will pass this 3 over there. 3 Now I apply algebra. I operate everything that has V1. I will have F1 out of 10. It's just this plus V25 11 over 30 volts 3 is equal to minus 7 thirds multiplied by 30. Here. And here it would be 3 volts plus 6 volts V3 equals minus. So our third equation. Okay, we now have 3 equations with 3 unknowns. We can solve it in many ways. As I have said in previous videos, you can use calculators. There are speculators who solve that. The internet is a program, or in this case I am going to use MATLAB. Okay, here I have. Let's notice that the first equation is 7 minus 4 minus 2. I'm going to put here. I'm going to call the matrix 7, space minus 4, space minus 2 semicolon to go to the other row. 7 minus 15,377. 15. 3. Here it would be 3, 6 and minus 11. 3 space, 6 steps left. And the matrix B, which would be what has the same, that is, what comes here minus 45 0 and minus 70. I put here minus 45 semicolon 0 semicolon minus 70 because this has to go for each row. And the solution variable is going to be A versus B. So I give it here. And it tells me that the voltage V1 would be minus 719 V2 minus 277 and V3288. Let's notice that since I have B1, B2, B3, this would be B1, B2. So the solution for this exercise would be B1 7 minus 7 volts. B2 would be minus 2.77 volts and B3 would be 2.88.